Welcome back to Rges Pre-Algebra. Our assignment this week will cover 1.3, 1.4, and we're talking about order of operations and property of operations. Operations, the basic operations in mathematics are addition, subtraction, multiplication, division, exponents, and roots. Notice order matters. Let's look at our two examples. If you have 12 plus 6 times 5, and I decide to do it in the order I see it, I first would say 12 plus 6, which is 18, times 5. That dot is a multiplication sign. And 18 times 5 would be 50 plus 40 more, which would be 90. But if I did it in another order and I decided to do my multiplication first, I would get 12 plus 30, and my answer would be 42. Well, this is a problem for us. In mathematics, we never want more than one answer, so which answer is the correct answer? We have come up with rules that everybody in mathematics applies. They understand the proper order in which to do things so that we can all be expecting the same answer. And these are the rules, or what we call the order of operations. First, you do grouping symbols from the inner to the outer. Examples of grouping symbols would be parentheses. Sometimes you'll see brackets. Sometimes you'll see braces. And the one you might not think about is a division sign. A division sign like this, or a fraction bar, means that everything above would be done, and everything below would be done. We're assuming these parentheses here, above and below, and the division is done at the very end. So that's an assumption that we call that actually one of the grouping symbols. Next, we would do powers and roots from left to right. We would do multiplication and division from left to right as we see it in the problem, and that does matter. And we would do addition and subtraction from left to right. Notice in grouping symbols, we would do it from the inner group to the outer group. In other words, sometimes I can have what we call nesting groups. So we will look at that in our examples. Our properties of addition and multiplication is the next thing we need to learn. What I have here for our properties, I have a column for addition and a column for multiplication, and what you're to think about when you use these terms to help you remember them. So, in other words, I have a commutative property of addition and a commutative property of multiplication. Commutative means to think, or to move. So if I'm commuting into town for work, that means I am moving my car from one place to another. So we get the word commute from commutative, or vice versa. Okay, so what am I going to expect is the order of these numbers changes. And notice on the left side to the right side of the equal sign, first I have the 7 and then I have the 3. 7 plus 3 equals 3 plus 7. What the commutative property is telling me is that I will get the same answer whatever order I do addition in. That would not be true for subtraction. Same thing with multiplication. I have changed the order of the numbers. First I write my 7, and then I write my 3. First I write my 3, and then I write my 7 on the other side of the equal sign. In fact, that is true. On the left side, 7 times 3 is 21, and on the right side, 3 times 7 is 21. So this equality is true, or the commutative property is true for both addition and multiplication. When I think associative property, I do not want to change the order of the numbers themselves, like I did up above in the commutative property. I don't switch the order, but I don't switch the actual order on paper, but what I do is switch the order in which I do the operation. So notice in the first example here on the left side of the equation for addition, I am first adding the 3 and the 2. Notice on the right side, I am first adding the 7 and the 3. That's what I mean by order. So I keep the 7, 3, and 2, 7, 3, and 2, in the same order on both sides of the equation, but I change which one or which group I do first. In multiplication, it looks the very same. I have 7, 3, 2, 7, 3, 2, but what have I changed? First here, on the left side, I'm multiplying the 3 and the 2. On the right side, I'm first multiplying the 7 and the 3. And what this property is teaching you is that the associative property is true for both addition and multiplication. That means if I do it in the order on the left and I do it in the order on the right, I have not changed. Let's make sure that's true. 7 times 6 is 42. 21 times 2 is 42. Okay. The identity property, I want to think what I start with on the left, the number I start with on the left, is going to be the number I end with on the right. For addition, what do I have to add to the 7 on the left to still keep a 7 on the right? And the identity property of addition has to do with the number 0. The identity property of multiplication is the number 1. What must I multiply by 7 on the left to end up with 7 on the right? The distributive property is not associated with either multiplication and division, or division because notice it has both operations. This is an addition sign. A 7 before any number in parentheses means multiplication. I could write 7 times 5 plus 3. I could write 7 times 5 plus 3, or I could just put the 7 next to the parenthesis, and it means that I multiply. All three of those mean the same thing. Well, when I distribute, what do? I take the number outside the parenthesis, and I first multiply it by the first one, 7 times 5, and then I add it, because this is an addition sign, to another multiplication, 7 times 3. So let's make sure that distributive property is indeed true. On the left-hand side, I would do what's in the parentheses first, so I would say 7 times 8, and that's 56. On the right-hand side, if I distributed it, I turned it into two multiplication problems that I'll add together. 7 times 5 is 35, plus 7 times 3 is 21. Adding them together, I do get 56. So indeed, the left side does equal the right side, and that's the nature of the distributive property. Now, what you need to do is make sure that you can when you see an example, you know which property is being used. And you do care both about the operation and whether it's the name of the property and the operation. For instance, you would want to say commutative property of addition, or you would want to say the identity property of multiplication, except when you have distributive property, which does not have an operation, a single operation associated with it. Okay, let's go ahead and look at some examples. Our first example for order of operations, notice that I will always use the dot symbol for multiplication, because once you get into algebra, you don't want to use that X symbol anymore, because we're constantly using variables, and especially the variable X, to stand for something else. So it's easy to confuse it, so we will start using dot for our multiplication. Now, what do I have to do first? Well, you have to, by the way I model this, I want this to be the exact way you do your homework, in this vertical order. This becomes important as we work through math later. So First thing you do is what's within the parentheses. I can do that, and because this set of parentheses does not interfere with the first set, I can do them both. So I put an equal sign on the next line. What's on the first line will equal what's on the second line. Copy everything down just as I see it until I get to the things I'm going to work with. 13 times 2 is 26. Copy down the subtraction. 6 times 3 is 18. Now, what do I do next? Next, I say I add or subtract from left to right. So I do this addition next. So 26 plus 5 more is 31. Copy down everything else. And finally do my subtraction. Let's see, I would have 31 minus 20 would be 21, and be 23. So, did I do that right? No, I did not do that right. Remember, for this problem, I told you that we do consider the fraction bar as a type of grouping symbol, so I need to do everything above, everything below. In this case, there's nothing to do, and then do the division. So everything above, first I would have to do what's in the parentheses, so this becomes 6 times 5 plus 2 is 7, divided by 3. And later we'll be talking about another approach to this, but right now we'll do that multiplication. That'll be 42 divided by 3, and that would be 14. I don't see a reason not to show you right now. When we are multiplying above the fraction bar, in spite of what I said, you are also free to cancel. So 3 goes into 6 2 times, and 2 times 7 is 14. And if you don't understand that yet, go ahead and do it the first method. Otherwise, feel free to do that also. Now, the last problem I want to show you, well, actually 2 more. 5 times 5 times 4 times 3. I want to remind you that because of the commutative or the associative property of multiplication, I can do these in any order. So look for multiples of 10, for instance. Things that go in evenly. Another way I could have done this would be a multiple. Well, let's just do it that way, okay? So I'm going to multiply it in that order. This would become 15 times 20. 2 times 15 is 30 with the extra 0, and that's 300. And the point here is that there are easier ways to multiply by looking at your order. The last example would be a similar concept. If you have a bunch of zeros, times 50 here. I have 3 zeros, so let's ignore them for a moment. Let's say 2 times 5 is 10, times 4 is 40, and add 3 zeros. So trailing zeros you can just gather up at the end. So again, what did I do? I said 2. I could have said 2 times 8, but I like 2 times 5 because that makes it 10. 2 times 5 is 10, times 4 is 40, and then write in my trailing zeros. So you'll have a lot of practice on that.